Hi everyone, this is our section 4.5 introductory lecture video. Section 4.5 is rather short. In this section we are looking at inequalities involving quadratic functions. So in the very top I've got this example. I've got a function x squared minus 4x plus 2. You will find that this function can be written in the following vertex form. X minus 2 quantity squared minus 2. And I have a graph of the function right here. Looking at the graph, there are some x values where the function is positive, and there are some x values where the function is negative. Looking at the graph, the function is positive for x values that are less than the first root, negative root 2 plus 2. And it is also positive for x values after the second root, square root 2 plus 2. Looking at the graph, it's clear that the function is, it has some values where the outputs are negative because there are parts of the graph that are below the x-axis. And the x values where the function is negative will be for all of the x values between the roots, but excluding the roots themselves. So if I gave you a graph of a quadratic function, you should be able to solve any inequalities involving the graph, or rather involving the function, just by looking at the graph. How do you tackle these types of problems algebraically, though? In order to solve quadratic inequalities algebraically, the first thing that we want to do is move everything over to one side using algebra so that we have a quadratic function on one side of the inequality sign. Then what? We will factor the quadratic function and solve for the zeros or the roots of the quadratic. This means to find the x-intercepts of the quadratic function. In step 3, this is something that you may have seen before, you may not have. I will talk about it here in this video and also in our lecture tomorrow. You will make a sign chart and you will plug in values before the zeros, between the zeros, and after the zeros, and you will keep track of the sign. The last step, you will write your answer to the inequality in interval notation. So let's take a look at an example. Looking at this problem on the very top, you need to solve this inequality. The first thing that I'm going to do here is I'm going to distribute the 6. The next step, following step 1, I need to move everything over to one side. Moving everything over to one side and writing the left-hand side in descending order according to the exponents, I have the following. The next step is to see if I can factor this quadratic function on the left-hand side. I can factor this. I need two numbers whose product is negative 36, whose sum is negative 5. Where did I get that negative 36 from at the very top? I multiplied the leading coefficient, which is 6, by the constant term, which is negative 6. 6 times negative 6 is negative 36. I need to resort to something like this because I don't know how to factor this right off the top of my head. I am using what's known as the AC method, or what I like to call the magic X, and I will resort to factor by grouping. So I need two numbers whose product is negative 36, whose sum is negative 5. These two numbers will be negative 9 and positive 4. I am going to rewrite the middle term of that quadratic function in terms of negative 9 and 4. So I have 6x squared minus 9x plus 4x minus 6 greater than or equal to 0. I'm going to draw parentheses here and here. From the first set of parentheses, I can factor out a 3x, and I'm left with 2x minus 3. What can I factor out from the second set of parentheses so that what's left inside matches up with the first set of parentheses? I can factor out a 2. Treating 2x minus 3 as one gigantic term, we can factor it out. And the second set of parentheses that I write here in this next line will be 3x plus 2. Okay, now what? Let me scroll back up to the directions. Move everything over to one side. We did that. Factor the quadratic function. We did that. Solve for the zeros or the roots of the quadratic. Okay, so I have this thing factored. When does the left-hand side equal 0? You should have that the left-hand side equals 0 when x equals negative 2/3 and x equals 3/2. Okay, now what? Following the third step, I need to make a sign chart. What exactly is a sign chart? In this section, a sign chart consists of the following. You draw a number line. You're going to write down the zeros of your quadratic. Let me write down the quadratic function here on the lower left-hand side of the screen. We are going to plug in numbers before these zeros, between these zeros, and after these zeros. And we are going to keep track of the sign of our result. I don't care about the actual number, I just care about the sign. So if I plugged in a number less than negative 2/3, so for example, negative 1, looking at that function, plugging in negative 1, what do you get? You will end up with something that is positive. You can verify this yourself. So 2 times negative 1 minus 3 times 3 times negative 1 plus 2. If you simplify that result and you multiply it out, you end up with a positive number. Once again, I don't care about what the number is, I just care about the sign. So I'm plugging in numbers, I'm plugging in x values that are before our x-intercepts, between them, and also after them, and we are keeping track of the sign. What is a number between negative 2/3 and 3/2? 0. If I plug in 0 into this function, what's the output? Is it positive or negative? If you plug in 0 into this function and you simplify, you should end up with a negative number. So we're just keeping track of the sign. Plugging in a number greater than 3/2, like 2. If you plug in 2 into this function and you simplify, you will end up with a positive number. Okay, so what? What exactly did this sign chart do? Let's look at the inequality. Let me circle it here in red. I need to find the x values such that that left-hand side is greater than or equal to 0. The sign chart actually tells us, which x values to plug in to get positive outputs, and the intercepts themselves will give us the zeros of that left-hand side. Looking at the sign chart, our function is greater than or equal to 0 for x values from negative infinity to negative 2/3, and also from 3/2 to infinity. So my solution, based off of the sign chart, let me rewrite the inequality, okay? this thing is greater than or equal to 0 when x is in this interval or it is in this interval. We need to use brackets here. Why? If you plug in those x-intercepts, you will get 0, and that will satisfy this inequality because this is not a strict inequality. Alrighty, everyone, that finishes up this lecture video. I will see you in the next one.